Welcome to the Introduction to Linked Data and MongoDB using Python course. We're going to start with how to represent facts using RDF, the Resource Description Framework. I have some data that we're going to load up in the data directory. And we're just going to inspect it right now so that we know what RDF is. So it's a gzipped file, and I'm opening that file, and for each line in the file, using this context manager, I'm going to take the first 100 lines only and print those. And so this is what RDF looks like. There are statements. They end in a period, and they have three components. Like you might have learned in English grammar, it's a simplification here. There's a subject, a predicate, and an object. And what's crucial with the resource description framework is that this is all expressed as relations between identifiers. So the subject is an identifier, a uniform resource identifier, an HTTP URL that represents this particular laureate with an ID of 72. And we express that as an identifier for it, a permanent identifier. If I were to go to this URI, we can see that it loads up a resource. This is the HTML representation of it. We can also do it in different representations. But this is a representation for Emilio Segre. There's also this predicate that expresses the attribute that you're saying of this statement. So this statement is saying that this laureate has a birthplace of this city. And if we looked up birthplace, that also is an identifier. This is part of the DBpedia ontology. DBpedia is an extraction from the info boxes of Wikipedia. And so this represents birthplace. And so rather than having the string value birthplace, we have this URI. And so that's what RDF is about, these resources and describing them using this framework. And so that's where the resource comes from. HTTP URLs, uniform resource locator, uniform resource identifier. So these are all resources, and subject, predicate, object, and they're all identifiers. Now, in the case where the object is sort of one-to-one with its literal representation, you don't need to have an identifier. So, for example, this RDF statement here says this laureate has a name, and by name I specifically mean this by name of this literal value. So this doesn't have to be a URL. It can be this literal value, and that's the only exception. And these literal values, implicitly, if there's no resource data type attached to them, they're considered just strings. But as we can see down here, this laureate has a date of birth of this literal value, but it's attached to this data type, which is also expressed as a resource, as a date. And this corresponds to an ISO 8601 date, 4-digit year, 2-digit month, 2-digit day, with dashes. And so that's all RDF is. It's a set of statements of these so-called triples, and you might have extensions to RDF where this universal relation is expanded a bit, where you might have a so-called quad. So not only a subject, a predicate, and an object, but another resource identifier for the so-called named graph. or namespace that this triple is in. But still you have a universal relation akin to, say, one table in an Excel spreadsheet or in a SQL database, one relation where these positions represent very distinct things, and this is the simplest form that we'll be dealing with in this course. Subject, predicate, object, just this triple format, where again, the subject and the predicate have to be identifiers. And in the case of linked data, using the linked data principle, they need to not only be identifiers, they need to be HTTP URLs that resolve. And then the object for RDF doesn't have to be an identifier, it doesn't have to be an HTTP URL, it can be a literal value, but it's either, it might be annotated with a basic data type, like implicitly that it's a string, or that it's a date, or that it's an integer, or something like that. And you can also have an annotation for these strings about their language. I wonder if, yeah, so here's an annotation of this laureate award, where it has a label of this, Nobel Prize in Chemistry, 1951, Edwin M. Macmillan, and it has this annotation using an ISO string for language. It's expressed in English. So these literal values that can be in the object place of a triple can optionally have two annotations. One, their language, the human language, and two, their basic data type. Implicitly, it's a string, but it might be a date, an integer, a Boolean. There are only a few in this XML schema namespace that are generally recognized by triple stores and databases dealing with this stuff. But in general, you could have something arbitrary here if you'd like. It's just that your software might not be able to recognize it. But it can still be anything. It's just an annotation for how one is to interpret this inline literal value. Okay, so now I'm going to use the RDFLib Python library and create a graph and open all of this file. And the suffix here is nt for n triples. So n as a variable, there could be many triples. And so we're going to parse those triples into the graph. And we're going to see a bit about how to use RDF to RDFLib to work with these triples. So for example, we can take 5 from all of the triples of the graph and use this deconstruction to say get the subject, predicate, and object and print them out. And so we can see this here in the Jupyter Notebook. We sort of pretty print these URIs. Also, in a name graph, we can have this concept of namespaces. So this helps with not having to print all of these out all the time if we kind of know what we mean in a certain namespace. Like we don't want to see data.nobelprize.org/resource all the time, or /laureate all the time, say. We can sort of have a prefix. And so, but this isn't just displayed by default, but if we do something, say using these registered namespaces, and these are the namespaces that are registered by default because they're so common, we can sort of print them using a certain format, using the namespace manager, and we can get an output like this, where, let's see, we can see here we print out RDF :type. So rather than print out this whole URL for RDF syntax namespace hash type, we replace that whole thing with this. And so this is a shorthand where you can just see RDF type or RDFS label. These things happen a lot, and so this makes things a little bit more readable because you can have these shorthand aliases for your namespaces. So if we do something like formalize this a method here into this function where we want to pre-print terms from the graph by applying our namespace manager to each of those terms. We have this helper function. Then we can do something like the following, where from RDFLib I import this namespace constructor, and I can say, okay, I have a bunch of nobelprize.org terms where they're hosting their controlled vocabulary. I'm binding that to this namespace and this prefix. So then when we do something like this, and we print a bunch of triples where specifically I'm doing a filter, a pattern match where I really don't care what the subject is at this point, but I want triples for which there's no filter on the subject. The predicate is RDF type, where I'm using the namespace, and there are built-in namespaces you can import, and this essentially builds up that full URL, and where the object is a Nobel laureate, meaning the object is the URL, this laureate, where that is that object, and when I do that, this is what I get. So these are the triples, 5 triples in the data set that where these resources are of type laureate, and so these correspond to the pages that we saw before. These can be resolvable. Whoops. So that just doing laureate itself resolved to something that will resolve the specification, as we'll see in a moment. The HTML page isn't so informative, but for the laureate resources themselves, there's a nice HTML representation. So then I can do things like, okay, find me all the triples where I want to know more about what this laureate is. Can you tell me about what a laureate is? So what can you tell me about a laureate? You know, what are some attributes in the database about this laureate class, this laureate category? And there's actually nothing in there, which is unfortunate. But the great thing about linked data is here we open this up and we saw, if I click this, it's in this RDF serialization, which maybe isn't so helpful to us, but if we can access that programmatically and essentially grab from our graph through RDFLib the RDF graph, the RDF statements, the set of RDF statements from that URI, we can parse that in, and now that's part of our graph. So our graph includes not only the data, but the metadata. And so then if we repeat that query from the top, we now have this in our graph, in our local database. We have metadata about this metadata term. So laureate is of type class, has a human readable label, and a laureate is a person or organization who receives one or several Nobel Prizes. So this is a description of this, a definition of this category directly from that's hosted on nobelprize.org. They're offering this machine actionable metadata definition, and they're claiming they're relating it to something else. So they're saying this is a subclass of this other term that's in this other vocabulary that's hosted by someone else. It's not Nobel Prize, but in case you have software that deals with agents, human agents or software agents, we're letting you know that this is also an agent. So if you're doing a search application where you're trying to find all of your different agents that are doing something, a Nobel laureate is the type of agent. We can find out more about this by binding this FOAF namespace to here. And if we do this again, we'll go ahead and see that, yeah, it's a FOAF agent. And again, we can follow our nose with this sort of thing. So this OWL class, what is that? So we already know that it's sort of in our namespace, and in fact, it's something that's very common. It stands for Web Ontology Language, but I guess it's nicer as an acronym OWL if they kind of switch around the O and W. And so let's find out what an OWL class is, and our database doesn't have that information currently, but we certainly can obtain it because it's a URI hosted by the World Wide Web Consortium, W3, and we can get the linked data using that name, using that HTTP URL name for that term. And now we can see, okay, OWL is, it's essentially it's a subclass of, or it's a type of RDF schema class. It's the class of OWL classes. Okay, and similarly, let's just look at this FOAF agent. What is that? We don't have information about that in our graph currently, but we can go fetch it because it's linked data. It's a link. We can go grab it, parse that whatever the set of triples are from this URL. We can get that into our graph, and then see what that is. So what xmlns.com / what this domain says agent is, how it defines it, because we're getting it from its domain name. So it controls the namespace using the domain name system. So a FOAF agent is, it's an OWL class. Okay, it's using some other vocabulary, term status stable. It's an agent, a person, group, software, physical artifact. It's also saying that it's an equivalent class to something else. So if we were to use this other vocabulary, Dublin Core Terms agent, this is a nice way of doing data integration, because this OWL equivalent class is an axiom. So our triple store reasoner can use this statement and substitute all instances of FOAF agent with DC terms agent. So you can see how these URLs really enable seamless data integration, like kind of putting together Lego blocks. Things just sort of connect because they have the exact same name for the same thing, or they use these very specific relations that are themselves URIs and have very specific meanings in order to do this. Also, one thing to note here, we might see, what is this VS? We didn't really have that before, DC terms. So we can print our namespaces. And a lot of times when you parse in graphs, it will include new namespaces. And so we sort of get these for free. So that's something to keep in mind. But hopefully this explains a bit about RDF, the Resource Description Framework. It's a model. It's not a data format. These things can be serialized as n triples, as we've seen. It can be serialized in memory as an RDFLib graph. We'll see it can be serialized as JSON using the JSON LD. But it's all about this universal relation, one table. In the simplest form, it's these triples, just 3 columns: subject, predicate, and object. And this relation is a relation among identifiers. So rather than literal names, these things are all HTTP URLs in the case of linked data. They're all resource identifiers, and it's a relation between these identifiers. And so you have this graph where all these identifiers are connected, and you get some wiggle room on that last aspect of the triple where the object can be a literal value. If it really wouldn't make sense to just have a 10-character string at a URL, like let's just include it in line. So you can do that. You can have those leaves of your graph, the literals, and also semantically annotate them with what human language that string is in, and also how it should be interpreted. again with a URI. So implicitly it's just a string, an XSD string, XML schema data type string, but you can also say it's a date, it's a Boolean, a lot of the primitive types that you're used to. Integer, a decimal, and that's often useful because, again, it's a string, so you don't have this issue with floating point precision, where you might want to represent a decimal number, and you were able to represent it as a string, but also say that it should be interpreted as a decimal rather than as a floating point number, where you might depend on how your system rounds off numbers. So that's RDF, and in our next video we'll be going into a bit more about how to represent not just the data but the terminology, all these categories and classes. So we'll get deeper into the specific namespaces of RDFS, RDF schema namespace, and OWL, the web ontology language namespace, and how we can represent terminology and make these kinds of RDF statements using the predicates and objects of these RDFS and OWL namespaces in order to define our terminology for our data set. So that will be next time.